Now we're going to talk about the event at Fukushima. The nuclear plant there was designed for an 8.2 earthquake, and it was subjected to an 8.9 earthquake. Nevertheless, all the reactors were shutting down as designed. Everything was going as planned until a tsunami came along an hour later and washed out the fuel tanks for the diesels that were supplying cooling water to the reactors. The wall to protect the plant against the tsunami was 6.5 meters high, but the tsunami was 14 meters, so it just washed over everything. This was a serious incident. It partially melted the two bundles that we just talked about. And the zirconium, when it's exposed to very high heat, will take the oxygen out of water vapor and leave hydrogen. There was a hydrogen explosion because hydrogen was formed by the very high temperature zirconium. Now, 6 workers were killed by the earthquake and tsunami, but nobody was killed by the radiation. Here's the human cost to Japan as of August 2011. The earthquake and tsunami killed 16,000 people, missing 5,000, injured 6,000. Homes were gone and life changed forever. The tsunami and earthquake destroyed a lot of homes along the seashore, and there was no place for people to go back. Now, at the Fukushima nuclear plant, nobody was killed, nobody was missing, nobody was injured, and the radiation levels are far too low to have caused any long-term health effects. And we'll see a little bit about that just now. When the event occurred on March the 11th, a little while later some radiation got released, and these two towns, B and D, were downwind of Fukushima, so they got a lot of the radiation. This level here of 45 microsieverts per hour is equivalent to about 400 millisieverts a year. That's less than rams or Iran, so it wasn't that serious. But you'll see that the radiation levels dropped off very quickly. That's because the radiation was caused by iodine-131, which has a half-life of 8 days. So in a month, the radiation level dropped to 1/16 of what it was, so it went down fast. Cesium-137 is the other main material, and it's soluble like potassium and sodium, so it washed into the ground and washed away in the runoff. So the radiation levels dropped to way down very quickly, and even this level is about 60 millisieverts a year, which is less than southwest France. The major problem at Fukushima was the economic disruption. That's what really hurt Japan. Initially, 11 oil-generating plants, 6 coal-generating plants, 1 hydro, and 4 nuclear plants were knocked out. 20% of their electricity capacity was out in 1 day. All reactors were shut down for safety inspections, all 54. 2 were restarted in July of 2012. There was 1 reactor that was being built. It was 35% complete. Construction was restarted in September of 2012. 30% of Japan's electricity came from 54 reactors, 49 gigawatts capacity. In terms of the world, the US has the most electricity generated by nuclear fission. It's almost 800 billion kilowatt hours. France was next with almost 400, and Japan was third with 260. So Japan was third in the world in generating nuclear electricity. Now we're going to talk about a comparison between Chernobyl and Fukushima, so you can compare and see what happened. In Chernobyl, the containment failed. In Fukushima, the containment held. And we'll talk more about the containment failing here in just a moment. The neutrons were moderated by graphite in the Chernobyl reactor because the Chernobyl reactor was designed to make plutonium. That's what it was designed for. And this one had a water moderator. Here, the procedures were ignored. This was an operator problem, a human error. This was a natural disaster. The boiler erupted violently, and the fuel bundles melted. Now, the boiler erupted violently because they were doing a safety test, and they got the reactor out of control. The power level went up very high, and the pressure went up very high in the boiler, too high, and it exploded and damaged the containments. That's why the containment failed. Now, this is the nuclear plant again. This is the nuclear reactor. This is where the meltdown occurred in these in this tube, these tubes here. This is the boiler that exploded and destroyed the containment. The evacuation was 1.6 millisieverts a year at Chernobyl and 20 at Fukushima. And the fire spread, the fire of the burning graphite spread 1,800 kilometers. So the radiation was spread 1,800 kilometers from Chernobyl, only 100 kilometers from Fukushima. And 10 countries had background levels in excess of 8 millisieverts above what their background radiation was. And nobody said a word about evacuating any of those people. None. They just lived through it. Japan had a maximum of 9 at one point for a day. 28 people died from radiation deaths at Chernobyl, and these were basically firefighters and people from the operating staff that were trying to fight the fire. No radiation deaths at Fukushima. So in summary, fire has many benefits. We have risk with fire, but we accept them and we minimize them through education. Nuclear energy has many benefits, as we've seen today. Nuclear energy has risks. We accept them and we minimize them through education, just like for fire. Radiation is important. We use it all the time. And waste management is relatively easy to do. Nuclear energy is the safest way to generate large quantities of electricity. We have to be realistic about nuclear energy because it's the only energy that has the capacity to replace all the fossil fuels for generating electricity. And if we ever have an energy shortage, the environment will be a disaster. All these trees we like out here will all disappear. Someone will cut the trees down for cooking or heating. This has happened in the past many times. It happened during the Berlin airlift. Before the airlift got started, I've seen movies of people cutting trees down on the boulevards in Berlin in order to have fuel to cook and heat with. Once the airplanes got in, they brought in oil and that stopped. This is an objective, science-based picture of nuclear energy. I'm a retired mechanical engineer. I'm completely independent. I've never worked anywhere for an energy company of any kind. I'm an affiliated member of Quebec's Global Environmental and Climate Change Center. That's my website at McGill with my papers and everything on it. This is nobody's full website. That's the Lightfoot Institute website. That's the Lightfoot Institute logo. The Lightfoot Institute has a charitable status we can take donations and give you a tax receipt. That's our logo, that's what we say about it, and there's the Lightfoot Institute. Thank you for listening. I hope you've all enjoyed this, and thank you again.